Good morning, Excel Geo. And what we are doing today, guys, is we are going to go over the concept that you learned in your Desmos activity yesterday. So what we did is we learned the relationship between a regular polygon's area and the area of a circle. Now, let's be aware, regular polygons, we know that they are equilateral and equiangular. And a regular polygon can be inscribed inside a circle, like this picture right here. So this is a hexagon, A, B, C, D, E, F. And this hexagon is inscribed inside the circle. Now let's just recall, when something's inscribed inside the circle, that means this circle goes through, hits every vertice of the regular polygon. So now when we take a look at this, we're going to start by going over just a couple of definitions so we are aware of terms as we move forward. So the first thing in this case is we know this is a regular polygon that's inscribed in a circle. Now, P is the center of the regular polygon and the circle. So we know P is the center of the regular polygon and the circle. All right, so that's a key thing. We need to know it's the center. All right, guys? So in that case, that is going to be the center of both figures. Now, the other thing I want to know is, that I want you to know, is that the radius of the regular polygon is a segment whose endpoints are the center and a vertex of the polygon. So when I talk about a radius of a regular polygon, all right, the radius of that regular polygon, all right, is a segment whose endpoints are the center and a vertice. Now, it's a vertex of the polygon. So this is quite simple. This is a hexagon. So a hexagon has 6 vertices. Therefore, that hexagon, that regular hexagon, will have 6 radii. So if you had an octagon has 8 vertices. So therefore, your octagon would have 8 radii. So the number of radii in the circle will be equivalent to the number of sides of your regular polygon. All right, so that's another definition we want to make sure we know. Now, the distance from the center to the side of the polygon. This is going to be something new. So now if I take a look at this and I want to start constructing some things, I can say I know PD is a radii, and I know PE is a radii. Okay, so that forms like a triangle. If I draw 2 consecutive radii, I form an isosceles triangle, and the reason it's an isosceles triangle is because I know that if this is a circle, the distance between the center of the circle to any endpoint, to any point on the circle is equivalent. So these 2 radii will always be equivalent if we're dealing here. So that means because these 2 are equivalent, this is always going to be an isosceles triangle. Now, the next thing I want to talk about is distance. The distance between the center and the side. So when we talk about the distance between the center of a polygon and the side of the polygon, is called the apothem. Now remember, when we talk about distance, the apothem represents distance. Distance is always the direct segment from that point to the, the direct length from that point to the segment. Now, when we talk about distance, the distance is always the perpendicular segment because we're talking about the shortest distance. So your apothem is always going to be a perpendicular segment from the center, and it's going to hit the midpoint of that side. Because if we have an isosceles triangle, it will always divide that side into 2 parts. So here is my apothem. That's an example of where my apothem is. And again, if you look at a figure, if you look at a regular polygon, the number of apothems will be equivalent to the number of sides. This is a hexagon, so that means I can draw 6 apothems in my triangle. in my hexagon. Now, the other thing, one more definition I want to make sure that we're aware of is central angle. The central angle of a polygon is formed by 2 consecutive radii. So we're going to say this, the central angle is formed by two consecutive radii. All right, so make sure we know that. That is what a central angle is.